Hey guys, here we are in our first set of examples for Module 6.1, where we're talking about properties of logarithms, rules for logarithms, ways to manipulate and work with more complicated logarithms. That's going to extend our discussion of logarithms, the basic definition of a logarithm that we got in Module 5.2, and it's going to help us solve equations as we look at logarithms and exponentials in equations in Module 6.2. So perfectly situated between our definition of logarithms and how we're going to apply logarithms to solving equations. Let's get some practice with properties of logarithms here. With our first property, the product rule of logarithms. You noted that in your pre-class work, in your textbook reading, but I'll put it up on the bottom of the slide here so we have that to remind us what the rule of logarithms says. And in fact, here on the bottom of the slide now, I've got the logarithm product rule set side by side with the exponent product rule because I want you to see that they are connected, they are related, and we don't have to think of it as just this new equation, this new rule that we now have to memorize that's completely unrelated to anything else that we've ever done. That's not true. On the left-hand side, the exponent rule that you know, b to the m times b to the n equals b to the m plus n. When we multiply, multiplication turns into addition of powers. On the right-hand side, the logarithm product rule, we are multiplying inside the parentheses capital M times capital N, and that turns into addition, a sum of two logarithms. And if you remember my description of a logarithm from Module 5.2, where I basically boiled it down to say a logarithm is a power, then on the right-hand side of this logarithm rule, we see that we are adding two logarithms. We are adding two powers. Just like in the exponent rule, we're adding powers. On the right-hand side with the logarithm rule, we are adding powers. It's actually the same rule written in log form versus exponential form. And our job right now, and in Module 6.1, is to get some practice applying this rule. So the rule says whenever you have a logarithm with a product inside the parentheses, then I can split that into a sum of two simpler logarithms. Like in question 1 here, where we've got log base 5 of 3 times x. I can split that into log base 5 of 3 plus log base 5 of x. A product within a logarithm can be split into a sum of two separate simpler logarithms. Similarly, in question 2, I've got log base 3 of 30x times 3x plus 4. Take a look at how I split this one up into actually 3 separate logarithms, because I've got 30 times x, which splits up into log of 30 plus log of x, and then another multiplication times 3x plus 4, so that I've got another sum of a separate logarithm, log base 3 of 3x plus 4. So two multiplications on the left-hand side split twice into two additions, two sums on the right-hand side. And then realize on the right-hand side here with the last logarithm, log base 3 of 3x plus 4, that I can't split that up any further, because this logarithm product rule doesn't say anything about the logarithm of m plus n. It's the log of m times n. It has to be multiplication. I can't look here and see addition and think that I can split that up further. No, it's a sum. I can only split multiplication. I can only split factors. And 3x plus 4, doesn't have any factors, can't be factored, so it can't be split using this product rule. That's it. We're done. Moving on to the next example, example 3, excuse me, where we are going the opposite direction. We're saying if I have two simpler logarithms, then I can actually combine them into a single logarithm where what's inside the parentheses, what we call the argument of the logarithm, is a little more complicated, but sometimes it's helpful to take several logarithms and pack them together into a single logarithm. And that we call that, up in the instructions here, condensing logarithms. So we're going to condense these two logarithms, log base b of 7 plus log base b of y, into a single logarithm, because if I read the product rule for logarithms at the bottom of the screen here, I can write a sum of two logarithms as one logarithm of a product. Log base b of 7 plus log base b of y is equal to log base b of 7 times y. I'm reading that logarithm product rule from right to left, which is fine. If they're equal, they're equal. It doesn't matter if we go from left to right or from right to left. It works both ways. And it just depends on what they're asking us to do in a particular example, or what our goal is in solving a particular equation later on. Sometimes it'll be more helpful to split it up into separate logarithms. Sometimes it'll be more helpful to take several logarithms and combine them into one. Depends on the scenario, depends on the situation. Right now we're getting practice with both to make sure that we see it work both ways. Question number 4 has us doing something similar. We have log of 15 plus log of 2 plus 4z. We have a sum of two separate logarithms. We're going to combine that into a single logarithm of a product of the two arguments. Log, a single logarithm of 15 times 2 plus 4z. So in all of these examples, make sure that you see how we are moving back and forth between sums of separate logarithms and logarithms of a product inside a single set of parentheses.